So this is the sixth question related to equivalent capacitance calculation which we are going to solve. Okay, so here we have these capacitors with the values given which are connected in this shape, this way, and we have to find out the equivalent capacitance between points 1 and 2. Now, uh, the thing which can create confusion in the mind of a beginner student especially who is getting started with circuit theory is these shorted terminals. Okay, these shorted terminals, okay, this shorted terminals and these two shorted terminals, this can create confusion so as to where to start solving or where to start reducing this circuit, because then it will be very difficult to identify the pattern. I discussed similar type of questions related to inductance and resistance, equivalent resistance and equivalent inductance. So we are going to use the same concept here. In case of shorted terminals, the thing which you can do is name those terminals. Okay, name those terminals, those points. So this point here is 1 and this is 2. This point 1 is shorted with this point, the shorted terminal, so this point also will be 1. This point is shorted with this point. There is no capacitance or any other circuit element in between. It means the potential at this point will be the same as the potential at this point. So this point also will be 1. Similarly, this point is 2. It is shorted with this point. So this point also will be 2. This point is shorted with this point. So this point also will be 2. And there are two unnamed terminals here. So let us just name them 3 and 4. Now, we have to find out the equivalent capacitance between point 1 and 2. Okay, the next thing to find out is which capacitors are connected in between which 2 points. Okay, which capacitors are connected in between which 2 points. We can see in between the points 1 and 3, 1 and 3, 1 and 3, 1 and 3. In between points 1 and 3, there are 3 capacitors connected, 15 microfarad, 35 microfarad and 10 microfarad. It means they are connected in parallel. Okay, so let us just see 15 microfarad, 35 microfarad and 10 microfarad. They are connected in between points 1 and let's say 3. In between points 3 and 4, in between points 3 and 4, let us just name them. 15, I am not using microfarad, I am just writing the values, the magnitude, and 10. In between points 3 and 4, there is a 20 microfarad capacitor. Okay, 20 microfarad capacitor. Microfarad. Now, in between points 2 and 4, 2 and 4, this 2 and 4, this 2 and 4, because of the shorted terminals, these all are 2, these are all 1. Similarly, in between points 2 and 4, there are 3 capacitors connected, a 10 microfarad, a 5 microfarad and a 15 microfarad. Okay, so the same, so we have a 15, a 5 and a 10. 5 and 15. Now, in between points 2 and 4, in between points 2 and 4. Now, in between point 1 and 2, there is a 40 microfarad capacitor. In between points 1 and 2, we have a 40 microfarad capacitor. So, in between these 2 points, there is a 40 microfarad capacitor. Okay, there is a 40 microfarad capacitor here in between points 1 and 2. Okay, so now we get a overall simplified circuit diagram. We can easily solve this diagram right now, this circuit diagram. It looked confusing here, but if we draw it in a more simpler way by identifying the points, the shorted points and other naming those points, we can convert it into a easier form to handle. Now, the equivalent capacitance of these three capacitors, okay, the equivalent capacitance of these three capacitors, because they are connected in parallel, the 10, the 35 and 15, between 1 and 3, they are connected across the same 2 points, 1 and 3, so they are connected in parallel. These three capacitors, okay, the 10, the 5 and 15, okay, the 10, the 5 and the 15, they are also in parallel across 2 and 4, so the equivalent capacitance also will be the addition. So let us just convert it into simpler forms. This is 35 plus 10 plus 15, it will be 60, okay, 60, 35 plus 10, 45 plus 15, 60. So let us just convert it into a simpler form. This will be 60 and this will be 10 plus 5, 15 plus 5, 15, 30. This will be 30. This is 30. Let us just write microfarad to avoid any confusion. Okay, now the 60 microfarad, 20 microfarad and 30 microfarad, they are connected in series across the points 1 and 2. Okay, they are connected in series across the points 1 and 2, the 60, the 20 and the 30. So the equivalent capacitance of this combination, these three capacitor combination, will be 1 by S equivalent, because they are connected in series. It is 1 by 60 plus 1 by 30 plus 1 by 20. The LCM will be 60, so it is 1 plus 2 plus 3 is equal to what? 3 plus 2 plus 5, 6. 6 by 60, which is 10 microfarad. The equivalent capacitance will be 10 microfarad. 60 by 6. It will be 10 microfarad. So we can replace this entire with a 10 microfarad. This entire thing we can replace it with its equivalent capacitance, which is 10 microfarad. Now we have converted this entire complicated circuit diagram into this simpler form, this two capacitor form. Okay, now see this portion, this entire portion, we have only this 40 microfarad, and this entire portion, has been converted into this 10 microfarad. Only the 40 microfarad is remaining. So this combination, the total capacitance now in between the points 1 and 2 will be simply the addition of these two capacitances, that is C12, because they are connected in parallel. Okay, the 10 microfarad and 40 microfarad, the equivalent capacitance will be simply the sum of the individual capacitors, that is 10 plus 40 equal to 50 microfarad. Okay, C12 is 50 microfarad. So this circuit was important because of this shorted terminals. Okay, because this can create confusion, so as to where to start simplifying the circuit, where to start reducing the circuit, because then it will be difficult to identify patterns. If we name the terminals, okay, this is 1, so the shorted terminal will also be 1, this shorted terminal will be 1, this is 2, the shorted terminal will be 2 and this shorted terminal will be 2. Then it will be easy to handle the circuit. Then we can find out in between the 2 points, whatever, 1 and 2, 1, 3, 1, 4, 2, 4, which capacitors are connected and how many capacitors are connected. Then we can easily handle the circuit. So we did that. We found out that these 3 capacitors, they are connected in between points 1 and 3. These 3 capacitors, they are connected in between 2 and 4. In between 1 and 2, that is 40 microfarad, and 3 and 4, that is 1 capacitor, which is 20 microfarad. Then we can easily handle the circuit, and we found out the equivalent capacitance as 50 microfarad. So we have discussed around 6 questions related to equivalent capacitance calculation. We discussed around same number of questions related to equivalent resistance and inductance. So I think we have a good idea about how to handle various kinds of circuits when it comes to finding out their equivalent resistance or inductance or capacitance. So we have a good idea because we have discussed a lot of questions related to that, starting from simpler ones, okay, simple questions, to a little bit complicated ones. So I hope you like this video, this series of videos, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.